Hello everyone, in this video we're going to talk about the real number system. So in this video, within the real number system, there's two main categories of numbers within the real number system. And so we're going to start with this diagram, this table if you will, on the screen where we have a left side and a right side. Now to the left of the table in blue we have some sets of numbers that we're going to classify within the real number system. So we're going to start with integers, or not necessarily in any order here, but integers, rational numbers, natural numbers, real numbers, irrational numbers, and whole numbers. So we're going to fit all of these numbers into this diagram, almost like a Venn diagram if you will, but it's going to help us classify these numbers. So first of all, the first one we can handle is real numbers. So first of all, everything we're going to talk about in this video will be real numbers. Later on, multiple courses from now, you will talk about imaginary numbers in Algebra 2. But for right now, through Pre-Algebra, we're just dealing with the real number system, and even through Algebra 1. Okay, so on the left side of my table, we're going to call these rational numbers. Rational. And then on the right side, we will put irrational. Okay. All right, so now we've handled rational, we've handled irrational. So now let's talk about what rational and irrational numbers are, and then we'll go down from there. So rational numbers can be written as a fraction. That's the key. It can be written as a fraction. So some rational numbers that we could think of, how about 1/3 or 1/2, okay? Now also, those fractions can be written as decimals, but two specific types of decimals. So 1/3, if you had a calculator and you did 1 divided by 3, you're going to see in your calculator it's going to be 0.333333333. So we would call that a repeating decimal. So we could write it as 0.3, and then we have that repeating bar over the top, so that means it's a repeating decimal. Now 1/2, if we did 1 divided by 2, we would just get 0.5. So it ends, it terminates. That's known as a terminating decimal. So we could write that as 0.5. So those types of numbers would be rational, and we're going to see that integers and whole numbers and also natural numbers, those are also rational numbers, but they're a little bit more specific. So these numbers that we've written so far, 1/3, 0.3 repeating, 1/2, and 0.5, those are rational numbers, but they're not integers or whole numbers or natural numbers. So we'll get into that in just a minute. Okay, so sticking on rational, we're going to draw in a box here that tells us these numbers are also rational, but they are a little bit more specific. So let's draw a box right here, and now we're going to write in the word integers. Okay, so integers. All right, now integers are going to be whole numbers and their opposites. Well, we have to know what a whole number is, right? Well, we'll get there in just a second. So essentially, we're going to write integers as -3, -2, -1, 0, 1, 2, and 3. And then at the end of -3 and +3, I'm going to put an ellipsis, which means it continues on in both directions, right? So we can, all of our positive numbers up to infinity, and all of our negative numbers down through -infinity, also including 0. So those would be integers. But notice how we've drawn that. Integers are also rational numbers. They're inside the rational numbers box. Okay, now we can get a little bit more specific over here within rational numbers. My box didn't draw there. Let's try and do it again. Okay, all right, so now we're going to write in whole numbers. Okay, so whole numbers. All right, so now whole numbers, we're going to take our integers, but it's only going to be some of the integers, no negatives this time. So whole numbers will start at 0, and then we continue on in the positive direction. Okay, so notice there's no negatives there. There's not an ellipsis before 0 because our whole numbers start at 0 and continue on. Okay, so first of all, we have, or where we're at right now, we have whole numbers. So let's take the number 0. Well, 0 is whole, 0 is an integer, and 0 is also a rational number. However, if I take -1, -1 is not a whole number, but it is an integer, and it's also a rational number. The number 1/2, it's not a whole number, it's not an integer, but it's a rational number. All right, the last subset we need to put over here is natural numbers. Okay, so our natural numbers, and these could also be called counting numbers. So natural numbers, think about how you would count things, right? When you're looking at a number of people or a set of items, what number will you start with? 1, 2, 3, right? We don't count like 0, 1, 2. We don't do that. We also don't count with decimals. So for counting things, natural numbers, they're going to start with 1, 2, 3 and continue on in the positive direction. So that's our subsets within rational numbers. So if I take the number 1, 1 is natural, it is whole, it is an integer, and it's also rational. So that's kind of how we're going to read that. Okay, the last thing we need to talk about are irrational numbers. Okay, so I think my spelling is a little bit off over here. I had an extra R on irrational, so let's fix that. Irrational. All right, that looks better. Okay, so now irrational numbers, they are going to be numbers that can't be written as a fraction. Well, what kind of numbers are those? Well, those are decimals that are non-repeating and non-terminating. So a classic example of an irrational number would be pi, right? Pi is approximately 3.1415926, so on and so forth, but it does not repeat and there is no pattern. So it continues on forever, so there's no way for us to write it as a fraction, so it must be an irrational number. Another good example would be the square root of a non-perfect square, right? So if I think about the square root of 36, oh, well, that's 6, right? Well, 6 would be a rational number, right? So the numbers that we would write over here would be the square root of a non-perfect square. So let's say, for example, the square root of 5, right? Well, the square root of 4 is 2, and the square root of 9 is 3. So the square root of 5 is just somewhere between 2 and 3, but it's a decimal, it doesn't repeat, and it doesn't have a pattern, okay? All right, so that's a little bit about the real number system and how we can classify numbers as either rational, and also integers, whole, or natural, and irrational.